Hello everyone, I'm back again with another video on force. Yes, Class 10 ICSE. Here we'll study about couple, equilibrium of bodies, kinds of equilibrium and principle of moments. Yes, last video we've seen how the body, if subjected to a force, will either be in a translational motion or rotational motion. So we've studied about rotational motion, but one thing for sure is a single force cannot produce rotation. For a rotational motion to be there, there are always two forces acting. So two forces which are equal and opposite. Yes, now here you can see force F here at point A and force F here at point B. They are equal amount of forces, but they are acting, they're opposite to each other, but they're not even acting at the same line. So line of force for this point A is here and the line of force for this point B is here. So they are forming a couple. So whenever you see a rotation, it is always the set of forces, two equal and opposite parallel forces. So these two forces are parallel to each other but not acting along the same direction. So they form a couple. So if you now look at the examples, it will be clearer to you that yes, when you turn the tap on, you cannot do that with a single side force or single finger. So you're applying the force in opposite direction. Now here, the first force is here in this direction, the second is parallel to this but in opposite direction, and their axis is also not same. The line of action is also not same. Same ways, if we look at the opening of a bottle cap, it is the exactly same. There are two forces, so we say they are couple. We define them as couple. So two forces cannot produce translational motion. Why? Because if you look at the resultant of these two forces, it is going to be zero if we talk about any one direction. So the resultant of forces is going to be zero in any direction. That is why the couple can only produce the rotational motion. Then how do we get the moment of couple or turning effect of couple? So consider there's a rigid rod, let's say AB, and I'm applying force F at A and force F at B. Now, if I have to calculate the moment of force at end A, how will I calculate? As we've studied earlier, it is the amount of force into the perpendicular distance. So moment is equal to force into the perpendicular distance. So here my force is F and the perpendicular distance is OA. That is going to rotate this rod in anti-clockwise direction. Then if I look at point B or end B, I'm applying a force F with a perpendicular distance OB, and that is also trying to rotate it in anti-clockwise direction. So if I have to calculate the total moment, it's going to be at point A plus moment at point B, which is equal to F into OA plus F into OB. Now, since my force is common, I can take it out common, and into the bracket it remains OA plus OB, which is nothing but my total distance D between the couple arms. So FA and FB, I call them as couple arm. So if I want to calculate the moment of couple, it can be either force into the perpendicular distance between two forces, or we can say the perpendicular distance between the couple arms. So this is first couple arm and this is the another couple arm. So I can take either force, because the force quantity, the number is going to be same. So either force into the perpendicular distance, which is equal to D. That gives me the moment of couple. Now the concept of equilibrium of bodies. So here, when there are number of forces, that is more than one, if there are number of forces acting on a body, but the state of the body is not changing, that means if the body or is not moving or it is already moving, it is not going to change its state. So resultant of all the forces is zero. So they do not change the state of rest or of a linear motion. That means if the body is in a state of rest, it will remain in a state of rest. If it is moving, it will keep on moving. That means the acting, as many forces you're acting on the body, it is not going to change the state of the body. That means body is in equilibrium. Now, first kind of equilibrium is static equilibrium. So what do you mean by static? Static is something wherein the object is not moving. So when I apply a number of forces on a body, but it doesn't produce any change in a state of rest. Yes, that means let us take an example of this block which is kept on a table. Now there are two forces acting on the body. First is the weight of the body which is acting vertically downward, and the next force is a normal reaction force which is acting vertically upward. Now these two forces being equal in magnitude but opposite in direction, the resultant force on the body is zero. So body is still remaining in a state of rest. In that case, I say the body is in static equilibrium. I say the body is in static equilibrium. So when a number of forces acting on a body produce no change in its state of rest or of linear or rotational motion, the body is said to be in equilibrium. And in our case, it is the static equilibrium for this particular example. Then the concept of dynamic equilibrium. Dynamic is something which is already in motion. So even if you apply number of forces, the body still remains in that position only. So let us take an example of an airplane. Now the airplane is, consider or suppose it is moving at a constant speed at a constant height above the ground level. So there are two forces acting here, the weight of it acting vertically downwards, and then there is this lift provided. Now, as long as your lift is not matching with the weight of the plane, it will not attain that height. Once the lift becomes equal to the weight of the plane, that time you say that the plane is moving with a constant speed at a constant height. That means your forces are equal in magnitude but opposite in direction. That is why the body is in a state of motion. That means the plane is moving with a constant speed and at a constant height. At the same time, we can see there is a drag also in this direction and the thrust which is pulling the plane forward. So they are also in the opposite direction but equal magnitude. That is why the state of the body, or rather the plane, is not changing. It is in a constant speed. That is what we call it as a dynamic equilibrium. So now let us see what are the conditions for equilibrium. First condition, as it is mentioned here, the resultant of all the forces acting on the body should be equal to zero. Exactly what we've just seen. Upward force and a downward force, or sideways, the forces are always in opposite to each other, but the magnitude is equal. So their resultant has to be zero for the body to be in equilibrium, either a static or a dynamic equilibrium. Then the algebraic sum of moments of all the forces acting on the body about the point of rotation should be zero. So we are talking about the first point talks about the resultant of forces which will be zero. So if resultant is zero, then I talk about the moment of force which is equal to force into the displacement, right? Force into rather the distance. Yes, the perpendicular distance. So algebraic sum of moments of all the forces on that body about a particular point should be zero. So sum of anti-clockwise moment equals to the sum of clockwise moment about the same axis. These are the two conditions to be met for the body to be in equilibrium, whether static or dynamic. Now we come to the important part of the topic, which is principle of moments. According to principle of moments in equilibrium. So here we are talking about the bodies which are in equilibrium or in a balanced state or in a state wherein they are not changing the state of either rest or motion. In that case, sum of anti-clockwise moment is always equal to sum of clockwise moment. Now, how do we understand this or how do we apply this? So let us take an example of a ruler. Yes, a meter ruler here is balanced and supported at a rigid support. Yes, and it has been balanced with the support here. O is the point, we can say it is a pivoted point. Then there are two weights, one W1 fixed at point A or end A, and W2 is the weight acting at point B. Now, how do I apply the principle of moment here? Principle of moment says sum of anticlockwise moment equal to sum of clockwise moment. So first of all, let us find out which force is moving or turning this ruler into anticlockwise direction. Yes, so it is the W2 which is trying to move the scale in anticlockwise motion or anticlockwise direction, and the W1 is trying to move the scale in clockwise direction. Yes. So now I have to calculate the moment. So anticlockwise moment is equal to moment is equal to W2 into the perpendicular distance here is L2. So W2 L2, and the clockwise moment is equal to you see W1, if I put the weight here, is going to move the scale in clockwise direction. So that is W1 into the perpendicular distance from the pivot, that is L1. So if I apply the principle of moment, it becomes W2 L2 is equal to W1 L1. Yes, this is what the principle of moment is. Now, this is about the verification, but unless we solve any question or a numerical, you would not understand how the questions of this type of principle of moments can be solved. So let us go and solve one question related to principle of moments. Now let us first read the question. So it is given here that on a seesaw, two children of masses 30 kilogram and 50 kilogram are sitting on one side of it at a distance of 2 meters and 2.5 meters respectively from its middle. So in a seesaw, obviously the center point is the pivot. Now, where should a man of mass 70 kilograms sit to balance it? So to understand this question, first of all, we will draw a rough diagram. So let us assume this is the seesaw and consider that the two children here are sitting on left side of it. So here, let me draw. First is a 30 kilogram acting at 2 meters from the pivot. Yes. So this mass is acting at 2 meters and then 50 kilogram at 50 kilogram at 2.5 meters. Now we need to find a position wherein a weight of, let's say, 74 kilogram will be acting to balance this, basically these two weights, but I don't know this distance, so I mark it as X here. Now applying our principle of moment, applying principle of moment, which is equal to clockwise moment equals to anticlockwise moment. Now, if you look at the diagram, you'll understand the 74 kilogram of weight will try to turn the seesaw in the clockwise direction. And at what distance it has been acted? It is x. So I write the clockwise moment as 74 into x. Then what is going to be our anti-clockwise moment? So this 30 kilogram and 50 kilogram. So now we will talk about the kilogram force. Yes, so 30 kilogram force and 50 kilogram force will act in which direction? Will try to move the seesaw in the anti-clockwise direction. So I write it here, 30 kilogram force into the distance, perpendicular distance is 2 meters, plus both of them are trying to turn the seesaw in anti-clockwise direction, right? Plus 50 kilogram force into the distance 2.5 meter. Here 74 kilogram force I would write into x is the distance, right? So this is how we apply the principle of moment. So if I calculate this, I'm going to get this is equal to 185. Yes, is equal to 74 into x. So if I calculate the value of x, I am going to get it 185 divided by 74, which gives me the distance as 2.5 meters. Yes, and where is it? On the other side, obviously. So if I have considered the 30 kilogram and 50 kilogram acting in the left side, definitely 74 is going to be on the right side. So what is the distance at which the 74 kilogram weight or mass will be acting at? 2.5 meters. So the man weighing 74 kilograms should sit at a distance of 2.5 meters so that the seesaw gets balanced. So this is the way you are going to get the questions and how you will apply the principle of moments and you find the exact answer. I hope this topic was clear to you, and if you find this video helpful, please like, share and subscribe. Thank you so much.